you're getting these nodes that are just running the interface to the sensors itself and the ability to be able to communicate. They're not running Windows 10 or Mac OS X or Linux or anything like that. So, and that's what the bulk of the operating system, the bulk of the memory is often sort of used up for. So you find that you can have really small amounts of memory to run these things in, and small amounts of power. It's got a couple of sensors in there with some ranges to it, and the sort of stats on the accuracy. How far it can transmit, for its range there. That particular one can sort of wirelessly transmit up to about 120 metres, about 30 metres indoors. So that's probably about the range like you get with Bluetooth for it. It doesn't use Wi-Fi for its communication. The power supply there is just a couple of 1.5 batteries. So 3-volt battery. Again, not something that you wouldn't run your laptop off 3 volts or something. There's another thing typical about these nodes is that normally placed around a building or off in the wild somewhere. You're either in the city attached to a building, perhaps out in the jungle on a remote moor or something like that. So they've got to work unattended to it. You may well be able to rig up some sort of solar power to it, but typically these things are unattended and they've got to last a long time. So a laptop, with a running battery life of about 3 hours isn't going to sort of be okay for it, or a phone to it. That's because they use all their inputs, all their battery power really on sort of screens for it. These things just running off 3 volts. Now using 3 volts, their power consumption with a CPU working for about an hour a day, they last about 6 months on 2 3-volt batteries. Now, although I'm just sort of showing you that one there, that's a purpose-built one. These are the sorts of things that manufacturers make for, say, perhaps putting around your home for smoke detectors or something like that, to sort of send it out. You can build in a transmitter to send to a centralised one. But you need something where you're possibly placing it on the ceiling, placing it someplace where you're not likely to get to it. And how much power does it use for sending data? If it's quiet, it doesn't do much. You don't expend much energy if you're not speaking or you're not moving around. It's only when you start moving around doing something that you expend energy. So when it's transmitting, it uses quite a bit more ampage, if you like. So you try to keep that transmitting to a minimum as well. And basically what we're trying to do is, because these things are battery powered, in general, we're trying to minimise that power consumption. That's the biggest drawback of our sensors, is whatever they're linked to is power supply. Now, we haven't been thinking about that in the lab, because your sensors are all linked to your laptop or your PC in the lab, which is plugged into the power supply. It's got a never-ending power supply there to it. But if you're going to build one of these for yourself that works outside, and it may be that it works with a Raspberry Pi, but even Raspberry Pis take a power supply. They don't work on batteries. They've got a little 12-volt power converter in it. So either you're going to need some power supply from somewhere, or a good battery that can last a long time for that sort of idea. Now we're going to have a look at the communication architecture, about how they communicate between ourselves, and there's a couple of slides just left over from last week that I want to have a look at. But when I look at the network ones, the following network and operating systems part is about the most techie that this particular set of lectures will get to, because it looks really at the theory behind how networks transmit information and things like that. If you've perhaps done a networks and comms module somewhere, or you're doing one, you might sort of have a better idea, but it can get a bit funny to get your head round for it, just to pre-warn you. The idea behind our sensor network, you'll have lots of these nodes dotted around. Now, a node is one of these things that we mentioned last week that can somehow sense its environment. It's got some sensors to build in and actuate something around it, but it's got a little bit of communication. to be able to send something out. Now, like that commercial one, they typically can't send it very far, so you'll have a little network of them, and if you want to send it onto the internet somewhere, you eventually need to end up with a gateway for it to go through, and somehow get it from that left-hand one and passing messages over to the sort of other side to sort of get out. And that green one over at the right-hand side, the gateway, that'll be the equivalent, say, of your router. And that's normally plugged in. That's normally got a proper power supply to work with. Because that's going to receive everything and transmit it on. And receive it coming back and pass messages back the other way. Now these sort of networks are very sort of typical working like this, and it's one of the things that in your assignment you asked to give a sort of an overview of the communication of different types of node, both how they're connected to the internet, if they are, where the gateway might be, what type of communication protocol they'll use. So it'll fill in with sort of bits that we're doing today and over the sort of coming weeks for it. So in terms of the networking, we've got these things. These are nodes that we've built ourselves. And as I say, try to get away from the idea of what we're doing in the labs, or think of those in the labs as being your nodes. But with it, just think of it that your PC is actually one of these sort of shrunken processors inside it. So we've got a distributed network, that top right-hand part of it. We've got things working together to communicate with each other for it. Now, for example, the Philips Hue lights, that's some smart lights. They all communicate using something called Zigbee as its communication protocol, and they can transmit their data about 30 meters. But the way, if you think of that sort of previous one as being, for example, a collection of lights for it, these smart lights, they may be able to sort of communicate with each other, but what they do, the one on the left is probably too far away from that gateway, from your sort of router. So what it does, it passes messages on, and each light bulb is capable of receiving a message and transmitting it on. So rather like at the minute, I can reach the back of the room, I can project my voice so that everybody can sort of hear it. If I started to speak a bit less, then you might have to do a bit of that old sort of whispering game where you sort of speak to someone. Nobody over there is hearing that. I sent a message to these two, and what they can do is retransmit that message over on through. But that in itself brings a few problems, we'll see. Similarly, everybody in this room can hear my message now, but people perhaps over in JDE can't hear it. We need to retransmit our message somehow over to there using a different communication. So we've potentially got this sensor network of a distributed system. We need to communicate between the things, but probably not using what you might have thought for wireless communication so far, like Wi-Fi. Wi-Fi just uses too much power. Wi-Fi will sap your battery within a day. But you've seen that with your phone, which has got a pretty good battery in it. If you just had a 3-volt battery in it, two of the little AA batteries, it probably won't last an hour or something, your actual sort of phone. So we use a different sort of protocol for our things network, that once we get to the gateway, then you're onto the internet. Now the internet uses existing protocols. Once you're on the internet, you must use HTTP or TCP/IP, all these internet-based protocols, because it's how everybody over the years has built up servers that run on the internet. They built up sort of messaging applications, and they all use set protocols. So once we're on that sort of cloudy bit, sending out from our gateway to the internet, we've got to use existing protocols. When we're in our own private things network, it's up to you what you use to communicate with to each other. And there's a variety of approaches that we can take and how you might sort of organise them. Depending on how far you want to transmit. And things that allow you to transmit further if I want to transmit further, I can start to shout, and maybe they'll hear me out there. Yeah, and no, please don't. But that, it causes me to be able to go further, but that takes more power. If I want to get more information over, perhaps I can start talking with you, some people here will understand that I'm talking about different modules, systems, different frequency spans and references, our triple standard here. Did you all get that? So I think you all sort of took that in. I can speak faster, but then you've either got to be very, very good at listening to it, or what you normally do is slow down. I'm already trying to fix sort of too much into it. So there's different ways of, when you want to get information over, either speak faster, and what that typically means in frequency terms is do it at a higher frequency. Transmit your data at a higher frequency, because when you're transmitting data, it's how fast the frequency is sort of going up and down, and it sort of reads high and low volumes. I'm grossly simplifying it here. But it's a frequency that basically decides how fast you can transmit it for it. But they've got certain maximum data rates, and Wi-Fi is pretty fast for a wireless one. It's faster than Bluetooth, it's faster than Zigbee, but it uses more power to get there. And you're restricted with only using certain frequency bands.